So we're not going to do anything new, but we are going to put things together, which will make it slightly more challenging. So we looked at trig identities last time. Hi, people. So we looked at trig identities last time, and before that, we looked at solving trig equations. Now we're going to try and do both at once a bit. So I'm going to start with a couple of examples and show you exactly what I mean. So let's start with an example where we're going to do both. So if I have, whoop, that's not a pen. I'm going to have root 3 times sine x equals cosine x. All right. What I'm going to do is I'm going to try. So is it possible for me to solve it like this? No, there's no sort of trig identity I can grab out of this immediately and do any substitution. So I need to do some rearranging and then some substitution. So I'm going to say this. Now, what is this close to but isn't actually? Right, it's almost 10. It's upside down, isn't it? Yeah, so what I'm going to do is I'm going to flip them both, okay? So instead of root 3, it's going to be 1 over root 3, and then I can flip these as well. Right? So these are the same. They're just inverses. And this is now 10, isn't it? So if I've got 1 over root 3, this is 10x. So then how do I get x by itself? Right, take the inverse tan of this. Someone type that into a calculator. Make sure your calculator is in degree mode. Oh, no. Actually, let's do both. All right, let's do degree and radians. So what have I got? 30. Okay, so if I've got 30, now the thing that you're going to be told is that I want answers between 0 and 360. So this is one of my answers, isn't it? So let's have a look at our cast diagram. So if I've got 30 here, what other quadrant am I allowed to be in? T. So that means this is my 30. So what's the other version I'm allowed to have? 210. I'm going to add 30 to 180. So these are my two solutions. If I wanted to do the same thing with radians, what's 30 in radians? Pi on 6. And then what's 210? Yeah, 7 pi on 6. All right, so either way, just make sure that you're paying attention to whichever version they give you, right? If they say 360, make sure your answer is in degrees. If they say 2 pi, make sure it's in radians. All right, let's do another one. All right. I'm going to do one where we're going to factorize. So let's say that I have sine x times 1 minus 2. Whoops, that's not an S. Cosine x equals 0, and I'm going to look for them between 0 and 360. All right, what's going on here? Someone give me an idea of how I can solve this. Try and think about straight algebra. You don't really need to think about trig functions at this point. How would you solve this? When we're factorizing to solve, like this has already been factorized for us. Well, that would be squared. Right, so that doesn't, I hear what you're saying, good place to start thinking, but it doesn't match that identity. I'm not going to rearrange anything. I want you to think about, okay, I'm going to rewrite this.
Go ahead.
Okay, if I had that without the sines and cosines, would you know how to solve this? What would be my solutions? X equals what? Or? Okay, right, so think about that, but what we're really saying, aren't we really saying when we do this, either this bit equals 0 or this bit equals 0, right? Anything times 0 is 0, yes? Right, anything multiplied by 0 is 0, so either this x equals 0 or this bracket equals 0. That's what's going on over here. So what I'm going to do is think about this separately. This equals 0 or this equals 0. And I'm going to solve them separately because I need multiple answers because I have multiple x's. So what is sine x when it's 0? What's x? 0. So let's have a think about it. Again, we can think about it in two ways. So if we think about our trig graph, when the value is 0, we're here, or we're here, or we're here. So what are my solutions? 0, 180 and 360, right? Those are where it happens. Or you can do it with the cast diagram, right? When it's 0, I'm at 0. The other time I'm at 0 is at 180. The other time I'm at 0 is back when I'm at 360. You can think about it on the cast diagram as well, or you can think about it on the graph. Either way, you will get these three answers. Now we need to look at this one. So I'm going to solve this for x. What should I do first? Move the 1. Is that right? What's wrong? Good. Leave the negative. All right. What do I do next? Thank you.
Yeah, that is actually.
Well, yeah, I guess you're right. Okay, so then what I would do is cosine x equals half. So then I take my inverse. So what do I get? In degrees. I've asked for it in degrees up here. 60. All right. So if I've got 60, think about it here. This is my 60. What other quadrant am I allowed to be in? So CAST. So I'm allowed to be down here as well. Good. So that means this is 360. Sorry, that means that's 60, which means that is 300. So these are my allowable answers. So when I'm putting them together, I should write them in numerical order. So this is x is 0, and then 60, and then 180, 300, and 360. So I've got quite a lot of solutions for this. You see what I'm doing? So if you've got something like this, you can just pull it apart and solve them separately. Let's do another example where I actually need to do the factorizing first. All right. You just wait. So I've got 2 sine x cosine x plus cosine squared x equals 0. And again, I'm looking for values between 0 and 360. So what should I do first here? Yeah, let's take out common factors. If you ever see a common factor, good place to start. So let's take out cosine of x, which leaves me with 2 sine x plus there's another one here equals 0. Now this is going to do exactly what the last one did. I've got 2 separate things and I'm going to solve them separately. So I'm going to think about this one equals 0, and then I'm also going to think of this as equaling 0. So let's start with this one. Again, let's have a think about our graph. Cosine starts where? 1. So this one's going to go down and back up again. So where cosine is 0, what's this? 90. And what's this? 270. So again, these should be my 2 answers. So therefore, x is 90 and 270. Again, if you look at your cast diagram, if you take the inverse of cosine, you're going to get 90, which is up here, right? So this is 90. And then we're going to be down here again at 270. So either way, it's 90 in this direction and 90 in this direction, right? From there and there. So it doesn't matter how you do it to me. I don't care if you like the graphs or the cast diagram, they will always work. All right, now let's think about what we could do with this one here. What's going on here? This is not an identity. I can't solve this. Does anyone have an idea about what I could do so that it is down to 1 trig ratio? So I either want it all sine, all cos, all tan. What do you think? I could do that. How could I do that? That's exactly what I want to do. I want to turn this into tan. Not quite. What do you think?
Like, since cos x is the same thing as cos squared over cos x, is that still using with that?
I'm basically just going to divide everything by cosine x. Right? So I'm going to decide if I just divide the whole thing by cosine x, I get 2 sine over cosine x. Then I get, oh, sorry, that should be a plus sign. Then I get cosine x over cosine x. and then 0 over cosine x, right? So I'm balancing my equation. So sine over cosine is what? 10. Oh, sorry, I didn't write my x. Oh, I'm not writing my x. That's terrible. Oh, what happened to my brain? Don't answer that. All right, that's what it should look like. Okay, so then what's this? 1, and then this is 0. Okay, now it looks like something I can solve, doesn't it, bless you? So now 2 tan of x equals -1. So then tan of x is -½ Okay, just going to move this over here so I've got room to do it. So if tan of x is -½ what's the inverse tan of -½ Okay, so we'll just leave it like that for now. Okay, so think about our cast diagram. So I am over here at the moment, aren't I? I've gone backwards 26.6 degrees. Am I allowed to give this answer? What was my limitation for answers? Right, 0 to 360. So this negative angle is a correct angle, but it's not a correct solution. So what I actually need to do is move into the quadrants I'm allowed to be in. So I'm allowed to be over here, aren't I? So I'm allowed, oh, sorry, it needs to be negative. So, needs to be negative, but I'm also allowed to be in this quadrant over here because this is also negative tan, isn't it? Right, tan has to be -½ So my solution must be negative. So then if that angle there is 26.6, this angle here is 180 minus 26.6, right? Which is 153.4. So that is my first positive angle that I'm allowed to have. Then I also need to keep going. So this angle here is 360 minus that, isn't it? Which is? 360 minus 26.6. Yep. I was very much hoping people would do this. 333.4. 333.4.
Isn't 26.6 negative?
You're not allowed to have a negative angle though, because they told us we must be between 0 and 360. So what I'm saying here is this, well, this is 26, that's the size of this angle. So yes, it's a negative. So you can write this as an, oops. You can write this as a negative if that's going to help you understand what's going on. But I'm allowed to have this angle here, and I'm allowed to have this angle here. Yeah. Okay, so that means all of my angles, let's go back and write them all out. So I had 2 over there. I've got 90 and 270 over there. So x equals 90, 153.4, 270, and 333.4. These are my allowable angles between 0 and 360. All right, I'm just going to save that. That's it. Oh, you mean as in that's all? Okay, would you like me to do another example? I've got more examples I can do, or would you rather have a go? Okay, have a go. There are still more worked examples you can have a look at in the book. I only did the first one. We're doing exercise 5.7. Please do them all. Yes. Yeah.